what will be the total flux through the faces of the cube as shown in figure 1.9 with sides of length A if a charge Q is placed at A, B, C and D. So these are the 4 points A, B, C and D. So if we place this charge small q at any of these points, then we have to find out the flux that is associated with this cube in all these 4 given situations. Clear? Now in order to find the flux, we have procedure of Gauss law. Now this Gauss law says that the flux through a given surface is equal to the net charge enclosed by the Gaussian surface divided by epsilon naught. Clear? Now in order to calculate this, what we have to do, we have to first enclose this given charge q. We have to enclose this given charge q inside some suitable Gaussian surface. Only then we can calculate the corresponding flux through the given cube. So for the first part, when we place the charge at a corner of the cube, so let's imagine a cube. This is the cube, this is the cube, and this given cube is part of this cube. This given cube is a part of the cube, and this given cube is 1/8 part of the cube, such that when we place this cube in this big cube as a part, so this point A becomes the center of this big cube, and now the charge is enclosed inside this imaginary Gaussian surface, or you can say a given surface. Now through this whole arrangement of 8 such cubes, clear? Through the arrangement of 8 such cubes, so the total flux associated with this big cube is equal to the net charge enclosed by the cube, that is q here, divided by epsilon naught. Now from the symmetrical considerations, so this one cube is 1/8 of the whole cube, so the flux through this given cube is equal to 1/8 times the flux of the bigger cube. So the answer for the part A is 1/8 into q by epsilon naught. Now when we place the charge q at point B, now that point B is the midpoint of an edge of the cube. So if we place the charge at this point, so we will follow the same procedure, but now we have to consider 4 cubes, not 8 cubes, just following the symmetrical considerations. So this is our given cube, and we have to arrange 3 more cubes such that point B is here. So when point B is here, and if we place a charge q here, so the flux through this given arrangement is flux through this big cube is equal to q by epsilon naught, and the given cube here in our case is 1/4 the part of this big cube. So in the case here for part B, we have the result 1/4 q by epsilon naught, means 1/4 of the total flux is shared by this cube. Now when the charge is placed at point C, now when the charge is placed here, so similarly in order to close the given charge inside some Gaussian surface, now we consider just 2 cubes side by side. So this is our given cube, and this is the another cube which we have to place with this given cube such that point C lies here. And similarly for the next part, when the charge is placed at point D, so we can solve both these points simultaneously. So whether the charge is placed at point C or the charge is placed at point D, and now the flux associated with this bigger cube, phi is q by epsilon naught. Clear? So in every case it is same. The flux through the bigger cube is this much. Now this part is half of this whole arrangement, so the flux associated with this smaller cube is half of the flux of the bigger cube. So this is the answer to part C and part D. Clear? So here what we have done, we have just followed the basic definition of Gauss law. First we have to enclose the given charge inside some suitable Gaussian surface, otherwise we cannot find flux. And once we have put the charge inside some suitable Gaussian surface here, so next we have followed the concept of symmetry in order to divide the flux associated with the different parts of the bigger Gaussian surface.